Hello, in this video, let us sketch the graph of a cubic. So sketch means to make the picture by hand, and that means we have to provide all the key points by hand. So the two things that we have to show is the y-intercept and the x-intercept. To get the y-intercept, we make x equals 0 and we solve. So if we do this, our f of x becomes 0 cubed minus 0 squared plus 4 times 0 minus 4, which is negative 4. So the y-intercept is y equals negative 4. To get the x-intercept, we make y equals 0. Now we have to solve 0 is x cubed minus x squared plus 4x minus 4. And to do this, we have to use the calculator and the fundamental theorem of algebra. The fundamental theorem of algebra tells us that the degree of the polynomial, which is 3, equals to how many solutions we're going to get. So fundamental theorem tells us 3 solutions is what we will get. Now let's look at a picture. So here with the calculator, let's make a sketch. So we type in the equation just as it is, just as it appears: x to the third minus x to the 2 plus 4x minus 4. And then here's the picture. We can see that the picture crosses the y at negative 4. That confirms our answer by hand. We see one intersection. It looks like 1, but we were expecting 3 solutions. That happens if the graph crosses. That means it's an odd multiplicity. So this answer might have happened once, might have happened 3 times. We don't know. But let's first confirm and see if that really is 1. So let's use the calculator to give us a good estimate, and then we have to use synthetic division to actually prove that it works or not. So here is the guess. It says 1. Perfect. So let's use 1. So to show that 1 actually works, so we suspect that x1 might work. So to show if it works or not, we use synthetic division. So here is synthetic division, and for it we use only the coefficients. So going back to the original, looking only at the coefficients, we have 1, negative 1, 4, negative 4. Now we're dividing by 1, that we think is the answer. Synthetic division, we add down and then we multiply diagonally. 1 plus nothing is 1. Diagonally, 1 times 1 is 1. Negative 1 and 1 is 0. 1 times 0 is 0. 4 plus 0 is 4. 1 times 4 is 4. And 4 and negative 4 is 0, which means that's a remainder. Remainder is 0, which means x equals 1 really does work, because there is no remainder. So we have proven mathematically that x1 actually is a solution. Now, where are the other 2 solutions? Well, we started off with a cube, and we just did a division by x, which means these are the coefficients, the numbers in front of the letters with 1 power less than what we started with. So we started with a cube. This is 1x squared plus 0x plus 4. So the other 2 solutions are in x squared plus 4 equals 0. Well, it's a quadratic, but we can solve it by simply undoing the remaining operations, following the order of operations. So to cancel plus 4, we minus 4 from both sides. And to cancel the square, we take square root of both sides. Each time remembering to put plus minus, because there will be 2 solutions. Now, when we take a square root of a negative, that means we're dealing with imaginary solutions. So square root of 4 is 2, but because we had a negative inside of it, that's 2 imaginary solutions. So the answer to our solutions is we have one real solution, and we have two imaginary solutions, 3 total as promised by the fundamental theorem of algebra. And with this we can then make a sketch, because we now have all the key components found out. So the y-intersect is going to be at -4, -1, 2, 3, 4, and then we'll cross at 1, and it will simply run through it and go up like this. And that's all the information that we can provide, because the other 2 solutions are not real, they're imaginary. And that's it, that's the sketch for the answer with imaginary solutions. And that's why we have to do this work by hand, because there is no other way to find imaginary solutions other than to get to remove from the original polynomial the factor of x plus 1. Then the square comes up, and the square can always be solved because we always have quadratic formula to solve it. Or maybe we can just undo a few things and get the answer that way. That's all for this video. Thanks a lot for your time.